Hello class, this is Mr. Hart, and in this podcast we want to continue our unit on the coordinate plane. And in this podcast we're going to look at how to find the area of any shape in the coordinate plane. Okay, so in previous math classes you probably learned how to find the area of basic shapes. Here are some ones you probably are familiar with. Okay, so like a triangle, for example. You probably remember that the area of a triangle is just equal to 1/2 the base times the height. Okay, a square is the area is just any side squared, right, or base times height. Rectangles, parallelograms, base times height, right? So you probably have found areas for these just common shapes. You're given the base, you're given the height, you can find the area. You may have even done the trapezoids where you do 1/2 the height times the first base and the second base. Okay, and so we've learned these formulas before of how to find the areas for these different shapes. But now we want to learn how to use these formulas when we're dealing with the coordinate plane, because we're no longer going to be given things in terms of their base and their height. Okay, we're just given points that describe the shape, and we're going to have to use those points to determine the areas. Okay, you use those points to determine what the base is, what the height is, what the side length is. Okay, and so it's not very hard once you find those different lengths, right? It's just these formulas that you've learned, previously. But we have to use coordinate geometry to find these different values. So let's just look at a simple example problem, and you'll see what I mean about having to find these different values. Okay, so let's say we have just a triangle in the coordinate plane, and we know that the points are 1, 2, 3, 6, and 8, 2 that describe this triangle. Okay, and we're trying to find the area inside this thing. Now notice we're not given a height, we're not given a base, right? We're not given what these lengths are. We're going to have to find them ourselves. So what we need to do is use these coordinates to help us figure this out. Okay, so what we want to find is this height right here that describes the triangle and this base right here. Okay, once we have those two lengths, the area is very simple. It's just equal to 1/2 base times the height. So the question is, we know the formula, that's easy, it's finding these values. Okay, so what we need to do is use these points to figure out the values. So this point right here is at 3, 6, and this point right here is at 1, 2. So this side on the bottom is at a height of 2, and this side on the top, or this point on the top, is at a height of 6. So we can take the difference between this y-coordinate and that y-coordinate to give us the height. Well, 6 minus 2 is going to give us a height of 4. Okay? And then for this bottom side, the base, we can use the x-coordinates. So this coordinate right here and that coordinate right there tell us that it's at 8 here, 1 there. So that side length is going to be the difference. 8 minus 1 gives us 7. Okay? So that's the base. So now it's really easy to finish the formula. Okay? We have the base that's equal to 7. We have the height, it's equal to 4. Okay, so all we have to do is plug it in. So area equals 1/2, the base is 7, the height is 4. You plug that in and you're going to get that that is equal to 14. Okay, so the area is 14 in this case. Okay, or sometimes you might see people write it as units squared. Okay, I won't worry about it for our class. The area is going to be 14, okay, when we're describing it in our class. But just so you know, some people do write the units squared at the end, okay? But there you go. So now we know the area of that triangle, okay? And it wasn't too bad once we found the base and the height, right? It's just the simple formulas we've learned. We just have to use the coordinates to our advantage to help us figure these values out, okay? So let's go ahead and try another one. So let's say we have this parallelogram over here. Okay, and it's described by these points. All right, so go ahead and try on your own. Maybe pause the video if you need to and see if you can figure out the area of this parallelogram. Okay, but if you go through, you should be thinking that, hey, first thing I need to do is find the formula for the area. If you look at the formula for the area of a parallelogram, it's still just the base times the height, just like a rectangle. So when you're trying to find the base and the height, we can treat this side right here as the base, and then this side right here as the height of that parallelogram. So when we're trying to find this base right here, we say, well, 5 is the height at that point, 2 is the height at that point. Okay, so the difference is going to be the base, which is 3. Okay, 5 minus 2. And then for the height, we know it's at 5 on this side and 0 on that side. So 5 minus 0, that's going to give us 5 for our height. So we got these values, we just plug them back into the formula. So the base is going to be 3 in this case. The height is going to be 5. So we just do area equals 3 times 5. That's going to give us an area of 15, or 15 units squared. Okay? So there we go. That's the area of that parallelogram. All right? So if we're dealing with these simple examples where the points line up well with the coordinate plane and the sides line up well, okay, we can just use the values of the points directly to determine what the base and the height are. Okay? However, there are some trickier examples where we don't have a nice alignment with the coordinate plane. Okay, for example, let's say we're trying to find the area of this rectangle. Okay, you'll notice that the sides aren't lined up with the coordinate plane. It's not nice and easy to find these sides. Okay, so we can't just take the difference between these points. Okay, so there's two different methods that we can do. Let me show you the first method. And the first method is to use the distance formula to determine these side lengths. So recall that the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And so when we're trying to find these different side lengths, okay, because the area of a rectangle is the base times the height, we're going to have to use the distance formula and find that side right there for the base and that side right here for the height. Okay, and so if we look at our formula, area equals, I'll just write it down here to remind ourselves, area equals base times height. And so we need to find the base using the distance formula. So we got 5, 2 and 7, 3. So the distance for the base, or let's write it this way, the base itself, right? The distance for the base is going to be equal to the square root of all this stuff plugged in for these points. So x2 is going to be 7, x1 is going to be 5 squared, plus y2 is 3, y1 is 2 squared. Okay, so that's going to give you 2 squared plus 1 squared. That's 4 plus 1, or square root 5. Okay? All right, so that would be our base. You could do the same thing for the height right here. Plug it into the distance formula, find the area, and so on. Okay? But notice how quickly this is becoming, very unruly to work with, especially if, in this case, it's even nice because the points line up with the sides. What if you're trying to find the height of like a triangle, for example, right? You may have to do a couple of distance formulas. And so we're not going to use this method very much of using the distance formula to find the area. Okay, let's look at another way we can do this, okay, so that we don't have to plug it into the distance formula all these times, okay? So the second method involves what we call the box method. Okay, so let's say we're trying to find the area of this trapezoid looking shape right here. Okay, if we wanted to treat it like a trapezoid, we'd have to do the distance formula at least 3 times. One for this side right here, one for this side on the bottom, and one for the height, which I don't even know how you get a point to get the distance for the height, right? So we can't really use the distance formula for this problem, right? We need a different method. And so what we do is what we call the box method. And we're going to draw a box around the outside of that shape as it's shown over here on this picture, okay? And so when you draw that box around the shape, suddenly you have really simple areas to find. Okay, you can find the area of the box really simply. You just do the base times the height. And then you have areas of triangles and squares that you make. And then you find those areas, okay, to find the inside area. So what you'd do is you'd find the area of this box, find the area of all the shapes, minus them off, and that gives you the area of the shape you have left over. Okay? Let's try an example problem and see if we can figure this out. So we're trying to find the area of this trapezoid right here. And again, it's kind of ugly. We can't use the distance formula. So let's do the box method instead. So we're going to draw a box, okay, around the outside of this shape. Okay, and now what we're going to do is find the dimensions of this box. Okay, so you'll notice it starts at 1 and goes to 8. So the whole side is 7. Okay, that whole base length is 7. And it starts down at 2 and goes up to 5. So that whole height is going to be 3. 5 minus 2. Okay, 5 minus 2 gives us 3. So the base of this big, huge box is 7. The height is 3. So the area of this whole box is the base times the height, which is 7 times 3, which is 21. Okay, so that whole box is 21 in area. So now we just need to minus off the area of those little triangles that we made, and we'll know how much the whole shape is. Okay. So first we got to figure out the dimensions of each little triangle. Okay, so this triangle right here goes up by 1 and goes over from 1 to 4, so it goes over 3. This triangle goes over from 4 to 8. That's going to be a width of 4. It goes from 5 down to 4. That's going to be a height of 1. This triangle goes from 4 down to 2, which is a height of 2, and it goes from 8 to 2, so that's a width of 6. This triangle right here has a width of 1, and it goes from 2 to 4, so that's a height of 2. Okay, so there we go. We got all these dimensions of the triangles. Their areas are going to be 1/2 the base times the height. Okay, so 1/2 times 1 times 3 is going to give this an area of 1.5. 1/2 times 4 times 1 is going to give this an area of 2. 1/2 times 2 times 6 is going to give this an area of 6. And 1/2 times 1 times 2 is going to give us an area of 1. Okay, so now that we have all the areas that are on the outside, we minus those off from the total area, and that's going to give us the area of this inside shape. So all we do is say that the area equals the area of the whole box, the big huge box, minus 1.5 minus 2 minus 1 minus 6. Okay, and so the area on the inside, if you plug that in on your calculator, 21 minus 1.5 minus 2 minus 1 minus 6 gives you that the total area of that inside shape is 10.5 or 10.5 units squared. Okay, so there you go. This trapezoid has an area of 10.5. Okay, now I know that seems like a lot of work, but keep in mind it's better than using the distance formula. I promise you, doing the distance formula 3 or 4 times is not as easy as doing this. So just as a review of the steps, make the box, find the area of the whole box that you made, the whole rectangle, find the area of each little triangle or square or whatever it is that you're taking out of the box, and you minus those off to find the area of the shape you're looking for. Okay? All right, so that's what you're going to be doing for your homework on 2.3. Hopefully that makes sense. Let me know if you have any questions, and thank you for watching.